Okay, so we have this block, and this block right here is attached to this ball and socket joint through this long rod. And what we're doing is we're applying this horizontal force of 10 newtons, and we're applying a moment that has a magnitude of 3 Newton meters. And we're told that the block starts from rest, so our initial velocity is equal to 0, and we're asked to determine the speed of the block 4 seconds after we apply these forces. So the first thing we should do is draw our free body diagram. And when we do that, if this is the ball and socket joint, we have some reaction forces. So that's going right along the z-axis. Maybe one's going along the x and the y-axis if we're using Cartesian coordinates. But they're all going through this point B. And now what else do we have? Well, here's the rod, and here is the block. Now the block is going to have a weight coming down, and the weight is going to be equal to its mass times gravity. And because it's on a surface, a normal force is going to be pushing back on it. We're going to have this horizontal force. So this is pushing the block, and we're also going to have a moment, and this moment is this 3t, and this force right here is of course, the 10 newtons. Now, we know it's going to be at some different position in 4 seconds. So it's going to be over here. And we're trying to figure out the speed. So we don't know this final speed. We know this initial speed. This initial speed is equal to 0 because it starts from rest. What can we do? Well, if we look at the angular impulse and momentum about the z-axis right here, the z-axis is going right up. All these resultant forces are going to go away because they go right through this. This axis. And we can also ignore this weight and this normal force right here because they're parallel to this axis. They're parallel, they're going up the same direction of this axis. So the only forces that really come into play are this moment right here and this 10 Newton horizontal force. So if we look at the equation we have a initial angular momentum about plus the sum of the impulses, the angular impulses, is equal to a final angular momentum. And we know that this momentum, this angular momentum, is equal to a mass times a velocity times a distance. So right here, because our velocity, our initial velocity, is 0, this part of the equation goes away. We know that this part of the equation is not going to go away because we have this moment right here, and that's what this is, and we have this force that's going to create another moment right here. So this part of the equation doesn't go away, but we can solve for it. So if we put in what our moments are, we have this 3t, and this is integrated from a 4, because that's what we're interested in, to an initial time of 0. And this is dt. And we add this next moment. So right here we have a 10 times 0.4 dt. And this is integrated from 4 to 0. This is going to equal this second angular momentum about the z-axis. And this part is equal to a final mass times a final velocity times a final distance. And we know everything here except the final velocity. We know that our final mass, the mass of the block isn't changing, so it's still going to be this 5 kilograms. We know that the final velocity, well, that's what we're looking for. And we know that this final distance, it's on this long rod, so this distance is not changing as it as it moves around this point. So this final distance is still going to be this 0.4 meters. And let's just put units on to be consistent. Okay, so if we evaluate these integrals right here, this integral, we get 3t squared over 2, evaluated from 4 to 0, plus this integral right here is going to be 4, which is evaluated from 4 to 0. This is 4t, which is evaluated from 4 to 0. And this is equal to this 5 kilograms times the final velocity we're looking for times this final distance, which is 0.4. So if we evaluate these integrals on the bounds, if we plug a 4 in here, we get 24. And then this is going to be plus 16 is equal to 2 times a final velocity. And if we solve for the final velocity, we're going to get a final velocity which is equal to 20 meters per second. So that means at 4 seconds, this block is moving at 20 meters per second. If this moment of 3t newton meters is applied, a horizontal force of 10 newtons is applied, and the block starts from rest.